So good afternoon students. Once again we are back in the highway engineering lab or the transportation engineering lab. Now today we will be performing the Los Angeles abrasion test. Okay. Now in this test what we do, one thing that we see how the aggregate takes the load, as well as we will use something in this that I will be showing to you that also reduces the material due to friction. The main material over is your aggregates. Okay. Now we will sieve the aggregates. Now the sample or the aggregate sample that is being present here. Okay. Here we will do in 20 millimeter pass, 20 millimeter sieve pass, 12.5 millimeter sieve retained, and 12.5 millimeter pass and 10 millimeter sieve retained. Okay. Now this particular experiment and the impactance that I told you, this conforms to IS 2386 part 4. Now if you go through, or if I give you the lab manual, or if you go to the ISO 2386 part 4, you will see that this experiment can be done performing to category of A, B, C, D, E up till this much. Further, now depending upon the group, that whether you are performing A, whether you are performing B, whether you are performing C, in this type of category, you need to have different type of materials, that is using the different sieve sizes and the amount of material in different amounts. Okay, and there are some iron balls, so it will also depend on the type of iron balls. Okay, now why we are using this grade A? We are using this grade A only because the materials that are being present here, it is easier for us to collect, and this type of material that conforms to grade A. In any of the site, if you ever go, being an engineer, I told you in the impact value test also, that being an engineer you have to check the quality, or you have to see the abrasion value. You have certain limits after which you cannot allow that those aggregates to be passed on. Okay, so there can be A, B, C, D, E, F, any type. Okay, now so that once again the same thing I am repeating, that the people who are performing the experiment, so they can make you fool. So if you want, then you can perform the experiment by in your own hand. So if you see the manual and if you see IS code 2386 part 4, then you will understand that what are the different categories of the abrasion test and what are the different parameters that we take. For this experiment to be done here in this lab, the materials that we have will performing with grade A. In grade A, I told you earlier also, and I am repeating it once again, we will take the sample that conforms to 20 mm sieve pass, 12.5 mm sieve retained, and 12.5 mm sieve pass and 10 mm sieve retained. Now the total sample, that is the retaining part on 12.5 mm will be 1.250 kg, and the millimeter retained on 10 mm sieve will be 1.250 kg. Okay, so that means on and whole, as a whole, we will take the total sample of 2.5 kg. After the abrasion test, we will collect the dust sample, then we will sieve it to 1.7 millimeter. 1.7 millimeter sieve, we will sieve it, and the retaining material on 1.7 millimeter will work on that. The difference between abrasion and impact in experimental procedure is that what? That after the impact test we sieved it with 2.36 millimeter sieve and we had taken the past material into account. But in case of abrasion test, we will take 1.7 millimeter sieve and we will work with the retaining material on the 1.7 millimeter sieve. Okay. So now this is my material. So this is my total material. I have taken 2.5 kilo, rather 3 kilo material over here. Now I am putting it on the sieve. Here see what we have. We have 20 millimeter sieve, we have 12.5 millimeter sieve, we have 10 millimeter sieve. Okay. And this is the plan. Okay. Now the part. Now as I told you that we will take the sample of 20 millimeter pass, 12.5 millimeter retain. So the material retained on 20 millimeter, we are throwing it away. Okay. Now it is 12.5 millimeter sample. Okay. So this is your 12.5 millimeter sample. We will weight it, but first let us carry, or let us calculate, or let us put the. So this is your 12.5 millimeter retained material, and this is your 10 millimeter sieve retained material.
We have to wait. Now we have to weigh it in the weighing machine for 12.5 mm retaining, that is 1.250 kg required, and 10 mm retaining, that is 1.250 kg required. So as a whole, total 2.5 kg of sample. The weight of the empty tray is 811 gram. Okay. Now I have to tear it to take the net weight of the sample. Now I am taking the sample 12.50 mm ISC weightage. How much weight of the sample? Yes, my requirement is 1.250 kg or 1250 gram for 12.5 mm ISC retaining sample. So it is 12.5 mm retaining sample. Its weight is 1.250 kg or 1250 gram. This is my requirement for testing the Los Angeles abrasion test. Now again I am tearing the weight of the tray, and now I am putting the sample which is retained from 10 mm ISC. My requirement is 1.250 kg or 1250 gram, but here it is showing 1354. So much more material is there, so I have to reduce the material. Yes, the reading is now 1.250 kg, that is 1250 gram, which is retained from the 10 mm ISC. Okay, now we have to mix both these samples, previously retained from 12.5 mm ISC and now from 10 mm ISC. The total net weight of the sample is 2.5 kg. Okay.